Hello children, today we shall start with the next topic, that is chemical bonding. So in the previous video we have also seen what is a chemical bond. That's a force of attraction between the atoms of a molecule. So we have two such types of bonds, that is electrovalent bond and a covalent bond. So first let us see the electrovalent bond. It is also termed or called as an ionic bond. It's called an ionic bond because it is formed by the formation or by the attraction between two ions, that is a positively charged cation and a negatively charged anion. So ionic bonding is a type of bonding where electrons are completely transferred from one atom to another atom or group. So what happens by this transfer? Ions are formed. And since the ions are having opposite charge, the ions have a force of attraction which holds them together. So the strong force of attraction between the oppositely charged positive and negative ion results in the ionic bond or electrovalent bond. Formation of sodium chloride. So let us see how the formation of sodium chloride ion molecule is shown. So sodium ion loses an electron, the electron that we can see in red color, to chlorine atom, and both of them form ions. Sodium forms a positive ion. Why it forms positive ion? Because it has lost an electron, that means it has lost a negative charge. And chloride forms a negative ion because it has added an electron, it has added a negative charge, and hence it forms a negatively charged anion. Now since sodium is positively charged and chloride is negatively charged, the oppositely charged ions are pulled towards each other because positive will attract negative. So thus a formation of sodium chloride takes place. I would like you all to note, children, that if there is a question, draw a structure of sodium chloride, in that case you should only just draw the structure of sodium chloride. But the moment your question is draw atomic structure to show the formation of sodium chloride ion, in that time you need to show the entire formation. That means you will have to show the atoms, that is atom of sodium and atom of chlorine, and forming the molecule of sodium chloride. So the entire structure that you can see on your screens will have to be done in case you need to show formation of sodium chloride. Next, this is an example for the formation of magnesium chloride. So the rule remains the same. If the question says show an atomic diagram or an electron dot diagram to show formation of magnesium chloride ions, in that case you will have to show magnesium ion and the magnesium atom and the chloride atoms, and how magnesium ion and chloride ions are formed. Okay, so just let's discuss magnesium chloride. In case of magnesium, its valency is 12, so its electronic structure is 2, 8, 2. So magnesium has 2 valence electrons. Now to complete its octet, it will prefer to give out the 2 electrons, and that is why magnesium loses those 2 valence electrons to chloride. Now why will it not bond with only one chlorine atom? Is magnesium has 2 excess electrons, so that it completes its octet, and chloride requires only 1. So in such a time, another atom of chlorine comes to take one more electron from magnesium. So magnesium will give out 2 electrons, but chlorine will be receiving only 1 each. That's the reason we need 2 chloride ions to combine with magnesium to form a molecule. And the structure is as shown on your screen. A magnesium ion with the electronic configuration 2, 8 is formed, and chloride ions with the electronic configuration 2, 8, 8 each are formed. So now the 2 negatively charged chloride ions will be attracted to one single positively charged magnesium ion, and this is the formation of magnesium chloride. Now let's see it for calcium chloride. So in case of formation of calcium chloride, this shows you the electronic dot diagram. The previous two screens, let's go back. This is for magnesium and for sodium chloride. So in case of sodium chloride and in case of magnesium, we have seen atomic structure or orbital diagrams. Now, the case of calcium chloride, I have represented it with an electron dot diagram. If your question says show the electron dot diagram for the formation of calcium chloride, what you see on your screens has to be shown. So here, how is an electron dot diagram shown? It is just shown with the electrons in the valence shell. So we don't show the entire electronic configuration. The diagram for that is not shown. It's only the valence electrons, two electrons that are shown as dots, and that is why it is called as a electron dot diagram. And oxygen, if you see, oxygen's electronic configuration is 2, 6. It's not 8 here, there's a mistake in this. It is 2 and 6. Okay, 2, 6. And that is why it is having 6 electrons in its valence shells. It has 6 electrons in its valence shell. Yeah. And in this case, calcium loses 2 electrons. Oxygen will happily take those 2 electrons as shown here. Oxygen will accept those 2 electrons from calcium. Now oxygen has completed its octet as well as calcium has completed its octet. So both the participating atoms are converted to ions with the completed octet. And this is the formation of calcium chloride. So this is the structure you will have to show as you see on the screens if it's for a electronic dot diagram. But in case they have asked for the orbital diagrams, then in that case you will have to show the orbits, that is the first orbit with 2 electrons, second orbit with 8 electrons, third orbit with another 8 electrons, and the fourth orbit with 2 electrons for calcium. Oxygen will have 2 orbits, 2 and 8. So you'll have to show those 2 and 6. There's a mistake in this, 2 and 6. Okay, so this will have to be shown. Please note once again, there's a mistake on the screen here. What you can see, it should be 2 and 6. Oxygen's atomic number is 8, so it has to be 2 and 6 here. Okay, let's go ahead. Let's see what's a covalent bond. So a covalent bond is a chemical bond that is formed between 2 or more combining atoms by the mutual sharing of 1 or more pair of electrons called a covalent compound. So what's happening in this case? In this case, there's no transfer of electrons that is taking place, but sharing of electrons is taking place. Now we'll understand this by looking at a few examples. So only you have to keep in mind is electrovalent bond takes place when complete transfer means one atom gives out 1 or 2 or 3 valence electrons to another, and there's another atom which accepts these electrons. But in case of covalent bond, they mutually share their electrons. Let's see the most simplest example in a covalent bond, that is of a hydrogen molecule. Let's see the formation of a hydrogen molecule. So how is hydrogen molecule formed? Hydrogen atom, as we know, consists of 1 proton and 1 electron. It has 1 proton, 1 electron. And so 2 hydrogen atoms combine to give us a hydrogen molecule. So what happens in this combination? We see that the electron from each hydrogen is shared. As you can see here, one blue one represents the first atom and the red represents the second atom. So these electrons are shared. What do we mean by shared? They are placed in common space. You can see, as we can see, there is an overlap. There is an overlap of the atoms, and in this overlap, in the common space, the electrons are placed. So both share the electrons. So if you're talking of the first hydrogen atom, this hydrogen atom will say, these 2 electrons belong to me. And if you look at this hydrogen is going to say that these 2 electrons belong to me also. So both of them have actually only one electron, but they bring one electron in their common space so that both are able to share the electrons. So now, if you look at this hydrogen, it has 2 electrons. And if you separately look at the second hydrogen, it has 2 electrons. So this is the sharing of electrons. So the number of electrons did not increase or decrease here. There's no transfer that has taken place. Yet the atoms try to complete their duplet or octet in this manner by sharing. Let's see a few more examples here. The next example is formation of chlorine molecule. This is also an electronic dot diagram, and hence we can see only the valence electrons. In this, one of the atom of chlorine is represented with blue electrons, one is represented with the red electrons. So in this case, this electron will move this way and be shared in the common space. This electron will slowly move to the common space, and thus the sharing of electrons takes place. We can see one more example of oxygen molecule. In case of oxygen molecule, there are 4 electrons that will be shared. There are 4 electrons that will be shared. Means when one oxygen atom combines with another oxygen atom, both of them have 6 electrons each. So here what we can see that 2 electrons have come to the common space. Slowly the next 2 electrons also will move to the common space. So overall or totally they will have 4 electrons. So this electron is also supposed to move into this common space. This electron is supposed to move into this common space. Okay, and thus we will have, and thus we shall have, so what let's see. Yeah, so this electron will move from here, this electron will move from here. Okay, as we can see on the screen, and it will go and it will be placed in the common space 1 and 2 like this. So it will come into the common space, and we will see that we have got 4 electrons in the common space, and then you have 2 pairs here and 2 pairs of electrons here. So this is going to move inside. So in this diagram what we can see that only one shared pair is there in common space. This has also to be shown in the common space. So please refer to your textbook diagrams for this. Next, we shall go to the formation of a nitrogen molecule. As it is shown on the screen here, nitrogen, which has atomic number 7 and electronic configuration 2 and 5. So they bring 3 electrons each. Both the atoms of nitrogen bring 3 electrons each in the common space. So that makes it 3 and 3, 6 electrons are there in common space. That is 3 shared pair of electrons are there for nitrogen. So that's why it forms a triple covalent bond. It forms a triple bond. A bond is represented between 2 electrons. A bond is always represented between 2 electrons. So when you have 6 electrons in common space, it will be a triple bond. So nitrogen molecule has a triple bond. Oxygen molecule shares 4 electrons. So it has a double bond. Okay. So this is the formation of a nitrogen molecule. This is the orbital diagram for it. Next. So let's see all the types of bonds that we have studied. One is a ionic bond and one is a covalent bond. But in covalent bonds we have 2 types of bonds. One is a polar covalent bond and one is a polar covalent bond and one is a non-polar covalent bond. So what's a polar covalent bond and what's a non-polar covalent bond? So let's see the non-polar first. So here we have 2 atoms of chlorine which are of equal size. They have equal number of electrons and shared pair of electrons, that is 1 each from both the atoms. So in this case, in the case of chlorine, the pull is equal. If you see the force of attraction, the pull is equal on both the sides. And if you take an example of a hydrogen chloride molecule, Hydrogen atom is very small and a chlorine atom is much larger because hydrogen's atomic number is 1 and chlorine is 17. So because of the difference in size, chlorine tries to pull the electrons towards itself, and it has a small, that is a delta negative charge. Chlorine gets a delta negative charge and hydrogen has a delta positive charge. Because of this, there is some polarity, there is some pull towards chlorine. What is there? There is a pull of electrons towards the chlorine side. And this is what is called as a polar covalent bond. So now it is more easy to understand what is a non-polar covalent bond. So what's a non-polar covalent bond? When the bonding electrons shared, they are equal between the two atoms, that time there is an equal distribution of pull. So the electrons will be placed, the shared electrons will be placed in an equal space. It will not be more towards any one atom side. It is spaced equal distance from both the nuclei. But in case of chlorine and HCl, the electrons are pulled towards chlorine side. They are pulled towards chlorine side. And that's why it is called as a polar. Polar means polarity. It has a pull. It has a pull or attraction, a little more attraction, but not as much as that the complete transfer of electrons will take place. There is a slight pull. That's why we say delta negative charge. And in this case, when there is an ionic bond, directly we get a formation of a negative ion, that is an anion. So these are the differences between the ionic bond, polar covalent bond and non-polar covalent bond. So ionic bond, complete transfer of electron takes place. In polar covalent bond, slightly they are pulled towards the negative side or to the larger atom side. And in non-polar covalent bond, the electrons are placed right in between and there is a total proper mutual sharing of electrons that takes place. Now let's see formation of a hydrogen chloride molecule. And why does that polarity take place in hydrogen chloride? So hydrogen, if we see, it has only one electron in its outermost orbit. And that's the only orbit it has. And chlorine has 7 electrons in its valence shell. When hydrogen and chlorine bring that one atom for sharing in the common space, at that time, chlorine has more number of electrons this side. So it has a pull. It has a pull for the electron coming in from hydrogen. And that is why chlorine pulls the electrons closer towards itself. If you see, it is trying to show that chlorine has more pull towards HCl. So if you see the bond distance, there is more distance between hydrogen and the center where the electrons are shared. And from chlorine, the distance is lesser. So chlorine is pulling the electrons towards itself. So chlorine is an example of a polar covalent molecule. Okay. Next we see the formation of one more polar covalent molecule, that is water. In case of water also, when we see hydrogen atoms are very small in size. Hydrogen atoms are very small in size. Whereas oxygen atom is quite larger comparatively. So in that case also, oxygen has the ability to pull the electron slightly towards itself. It pulls the electron slightly towards itself. So it gets a small charge, that is a delta negative charge, and both the hydrogens share a very small delta positive charge. Next, we shall see the structure of formation of ammonia molecule. In this case, it's an electron dot diagram, so we can see only the electrons of the valence shell. So here, we require 3 hydrogen atoms to combine with 1 nitrogen atom. We know hydrogen has 1 valence electron and nitrogen has 5. So 3 hydrogens share electrons here with nitrogen, 1 each. So there's 1 bond between this nitrogen and hydrogen. There's 1 bond between this nitrogen and hydrogen. There's a bond between this nitrogen and hydrogen. And it leaves 2 electrons in the valence shell which are totally not used. That means in bonding they do not take place. So these electrons which do not take place in bonding, they are called as a lone pair. It's a lone pair of electron. So this lone pair of electron is present in ammonia molecule. So ammonia has one lone pair of electron. Next, we shall see the formation of carbon tetrachloride. Carbon has 4 electrons in its valence shell, and chlorine, as we discussed in the earlier compounds, has 7 electrons in its valence shell. So it wants only one more electron, but carbon here has 4 electrons and is ready to share 4 electrons. So in that case, 4 chlorine atoms combined with one carbon atom to give you a structure of carbon tetrachloride. Let's see the formation of a methane molecule. Similarly, just like your carbon tetrachloride, your carbon will share with 4 hydrogen atoms. So carbon is looking to share only one electron from its outer orbit with one hydrogen atom. So there is a bonding between carbon and hydrogen. There's a bonding between this carbon and hydrogen here. There's a bonding between this carbon and hydrogen, the third one and the fourth one. Thus, it gives us 4 covalent bonds in the molecule of a methane. So, methane molecule has 4 covalent bonds. So, CH single bonds are present. 4 such bonds are present in the structure of a methane molecule. Now the last thing we will see here, that is the difference between an electrovalent bond and a covalent bond. So electrovalent bond is a type of a chemical bond that can be defined as an electrostatic attraction between 2 atoms. So that is when transfer of electrons take place, the ions are attracted towards each other, whereas a covalent bond is formed by mutual sharing of electrons. The type of force of attraction is electrostatic for electrovalent bonds, and in a covalent bond there is a direct chemical bond between the 2 atoms. This direct bond is because of the sharing of electrons from the valence shell. The difference in electronegativity values of an atom should be higher than 1.7, and for covalent bonds it should be lower than 1.7. We are going to learn about electronegativity in our class next year. Then ions are involved in the bond formations for electrovalent bonds, but here atoms are involved. So when covalent molecules are formed, the entire atoms take part in the bond formation, whereas in electrovalent bonds, it's the ions that take part. So with this, children, we complete the chapter, that is atomic structure and chemical bonding. Thank you.